Hi everyone, Tina here, and today I'd like to talk about upper and lower bounds. You'll need to be familiar with this idea if you're doing the Higher GCSE course. I'll explain what bounds are, and then we'll work through a few exam-style questions. So let's start by looking at this. The idea behind bounds is this. When a measurement has been rounded to a given unit, the actual measurement can be anything up to half a unit bigger or smaller. As an example, the mass of a book, m kilograms, is given as 3.2 kilograms to the nearest 0.1 kilogram. Part A, find the error interval for the mass of the book, m. Now, an error interval is just an inequality for the interval in which the actual measurement can lie. To work it out, I like to draw a number line. Put 3.2 in the middle, and then because we're rounding to the nearest 0.1 kilograms, what would go on either side is 3.1 and 3.3. Now, to work out what numbers would round to 3.2, we need to think about what would be halfway between those two numbers. So on the lower end, it would be 3.15, and on the higher end, it would be 3.25. So we'll use those numbers for the error interval, 3.15 and 3.25. M will go in the middle, and then we need to think about our inequality symbols. So for this one, we're going to say that m can be greater than or equal to 3.15, but then it's going to be strictly less than 3.25. And those symbols are really important, especially the strictly less than bit, because if m was equal to 3.25, it wouldn't round down to 3.2, it would round up to 3.3. And that's not what we want. And that's the answer for the error interval. Part B, find the upper and lower bounds of the mass of the book. Now the lower bound, or LB for short, is just that smaller number, so 3.15 kilograms. And the upper bound, or UB for short, is 3.25 kilograms. Now let's have a look at some examples. Example 1. A rectangle has length of 21 centimeters to the nearest centimeter and a width of 5.3 centimeters to the nearest millimeter. Part A, work out the upper bound for the perimeter of the rectangle. So first of all, I'm just going to draw out a rectangle and I'm going to label it as 21 centimeters there and 5.3 centimeters there. Those are the rounded values. Then I'm going to think about the bounds for those values. So if we start with the 21 centimeters, again, I'm going to draw a number line, so 21 in the middle. It's been rounded to the nearest centimeter, so on either side, we'll put 20 and 22. Halfway between those values is 20.5 and 21.5. So those are the lower and upper bounds for that measurement. Now for the 5.3 centimeters, just watch out because it says to the nearest millimeter. So I'd think about what 5.3 centimeters is in millimeters first. So that's 53 millimeters. And then I'd probably draw my number line using 53. So this is in millimeters. Either side would be 52 and 54. Split down the middle, 52.5, 53.5. These are in millimeters. So then if we want the bounds in centimeters, we just need to convert them. So 5.25 centimeters for that one and 5.35 centimeters for that one. Now we're ready to answer the question. So upper bound for perimeter will just be all the upper bounds added together. So 21.5 plus 21.5 plus 5.35 plus 5.35 altogether gives 53.7 centimeters. And that's the largest possible value for the perimeter of the rectangle. Part B, work out the lower bound for the area of the rectangle. So this time we want to use the lower bounds for the measurements, and that will be 20.5 times 5.25. Times in because we're finding the area in this one. And that gives 107.625 centimeters squared. Example 2, V equals IR. I equals 5.92 correct to 2 decimal places, and R equals 12.356 correct to 3 decimal places. Work out the upper bound for V and give your answer to 3 decimal places. So again, this question is about bounds, so I'd probably start by finding the upper and lower bounds for each of the letters. If we start with I, number line, 5.92 in the middle. Now that's been rounded to 2 decimal places, so either side we're going to have 5.91 and 5.93. Split down the middle to find the bounds, 5.915, 5.925. And then if you want, you could also write that as an inequality or an error interval with I in the middle, and that would be 5.915, 5.925. Similar process for R now. So number line, 12.356 in the middle. That's been rounded to 3 decimal places. So on this side, it's going to be 12.355, and on this side, 12.357. Split down the middle, 12.3555, 12.3565 If you wanted to write it as an error interval, you can, and it would look like this. Now we have all of the bounds, we just need to apply them to the particular question. So we want the upper bound for V. That means we want to use the upper bounds for each of the measurements. So that's 5.925 and 12.3565. We're going to multiply them together. And when we do that, we get 73.2122625. All that's left to do is to round that to 3 decimal places for the final answer. So 73.212, 3 decimal places, and we're done. Last example, P equals E over T, where E is 812, correct to 3 significant figures, and T is 9.2, correct to 1 decimal place. By considering bounds, work out the value of P to a suitable degree of accuracy. Give a reason for your answer. Now, in this particular style of question, when it references suitable degree of accuracy, what that means is they want you to work out the lower bound and the upper bound and then compare them. So to work out the lower bound and upper bound for P, we need the lower bounds and upper bounds for E and T first. So let's work those out using our number lines. It's going to look like that for E. So if we split those down the middle to get the bounds, we're going to get this. And then let's do something similar for T. So 9.2 in the middle, 9.1, 9.3. Then we've got 9.15 for the lower bound, 9.25 for the upper bound. Now let's think about putting those together. So first of all, if we want to work out the lower bound for P, the equation is E divided by T. So if we want P to be as small as possible, that means we also want E to be as small as possible, but we actually want T to be as big as possible. Because when you divide a small number by a big number, you get an even smaller number. Therefore, we want the lower bound for E, which is the 811.5, divided by the upper bound for T, which was the 9.25. When you type that in your calculator, you get 87.729,72973, and then just leave that there for a second whilst we work out the upper bound for P. Again, P was E divided by T, so let's think about that. If you want P to be as big as possible, then you want E to also be as big as possible. So starting off with a big number and then dividing by a small number. That will give you the biggest possible value of P. That translates into using the upper bound for E, which is there, 812.5, divided by the lower bound for T, which was 9.15. When you type that into your calculator, you get 88.797,81421. And now we're ready to compare those two answers. So if you scan across both of the answers, we're trying to figure out what would both of those numbers round to. Is there a number that they would both round to that's the same? And then looking across this, if we rounded both of them to one significant figure, we would actually get 90 in both cases. That's as far as we can go with it, because if we tried to round any more accurately, we wouldn't get matching answers. We wouldn't get 90 for both. Therefore, for a final answer, we're going to say P is equal to 90 to one significant figure. And the reason is because both the upper and lower bounds round to 90 to one significant figure. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.